This is tutorial 3, question 3. And in this problem, we have two channels. We have a trapezoidal channel, we have a circular channel. Both of these channels have an incline of 1 in 1800, main constant equal to 0,011. First of all, we have to calculate the discharge in cubic meters per second in the trapezoidal channel. Alright, so having a look at these two cross sections, if we look firstly at the trapezoidal channel, we can calculate what the depth value is using our tan. 30 degrees equal to 150 over d. So d would equal 259.8 millimeters. Also now sine 30 degrees is 150 over w, and w is 300 millimeters. We get to 30 degrees by taking 90 minus 120. So let's look at the discharge through the trapezoidal channel first. That's our Manning formula. We also know that Q is equal to VA. So we can now add A into the formula, or 8/2 square root of I. We also know that our hydraulic radius is equal to area over perimeter. Our area is equal to 600 times 900 over 2 times 259.8. Works out to be 0.19485 square meters. Our perimeter, 2 times 300 plus 600 is equal to 1200 millimeters. Our mean hydraulic radius is area over perimeter, so that would be 194,850 divided by 1200. Make sure that you're using the same units. 162,375 millimeters. So going back to our discharge formula, Q is therefore equal to 0,19485, which is our area. Manning constant is 0,011. RH is 0,162375 to the power of 2/3, and the square root of 1/1800, which is our slope. So from here we can look at a discharge of 0.124265 cubic meters per second. Secondly, is the depth of flow such that discharge is a maximum for the trapezoidal section? Prove your statement by calculation. Is this a maximum flow? Right. So we know that for max discharge in a trapezoidal section, we have a 2 plus nd is equal to d times the square root of n squared plus 1. So b over 2, substituting 0,57735 d is equal to d times the square root of 0,57735 squared plus 1. b over 2 is equal to 1,1547 d minus 0.57735 d, and b is equal to 0.57735 times 2d. And finally, we've got b is equal to 1,1547d. Alright, so what we've calculated now is for this particular channel, for maximum discharge, optimum discharge, B is must be equal to 1.1547D. B is equal to 600 millimeters. Therefore, D must equal to be 600 over 1.1547, which is equal to 519,615. And we know D is equal to 259,8. Therefore, not optimum. Alright, so we know that we're running less than optimum discharge. The next question we have to answer is the diameter of the circular pipe that will be able to convey the same as volume flow as the trapezoidal section in the first section of this problem. Right. So Q through the trapezoidal channel must be equal to the Q through the circular channel. We're also given a diagram the circular channel that we have to consider. So this is not an optimum condition. We know from what's given to us that this value is 2/3 of r. And that is r, that is theta, and we say that is a and that is b. So sine of a is equal to 2/3 of r over r. So a is equal to arc sine 2/3 r over r equals b. So therefore, theta is equal to 360 degrees minus a plus b, and theta is equal to 360 degrees minus 2 arc sine of 2/3 r over r. The r is cancelling out, and theta is equal to 360 minus 83.62 degrees, which would give us 276.38 degrees. So we've calculated what the angle theta is, and we know that if it's 330, that it is a maximum. So this is less than maximum. Alright, so the area of flow in the circular channel is d squared over 8 theta minus sine theta theta is 276.38 times pi over 180, which is 4.8 237 in radians. So a is equal to d squared over 8 4.8237 minus sine of 4.8237, and area is equal to 0.72719 d squared. First equation, perimeter P is equal to pi times d, which equals that's just pi d 276.38 over 360. 2,41187d. So that's another equation, and RH, hydraulic radius of the pipe, is equal to area over perimeter, or 0.72719 d squared over 2,41187D. That would give us 0,3015D, the third equation. Q pipe is a RH 2/3 over N square root of I. But we know that that is equal to Q in the trapezoidal channel, and we have that already. So we say 0,124 265 is equal to 72719 D squared times 0,3015D to the power of 2/3 powered by 0,011 and times 1/800. So D to the power of 8/3 is equal to 0,124265 times 0,011 over 0,72719 times 0,3015 about 2/3 times the square root of 1/1800, and that would give us the value of D of 0,5227 meters. So that is the diameter of the circular channel that would give us the same discharge as the trapezoidal channel.